Not all coffee beans that go into your cup are created equal. Neither are all IC that go into your SSD.
A good cup of coffee is always a great way to perk me up. So many things affect the quality of coffee, and it all starts with choosing the right beans. Their origin, the altitudes at which they are grown, their variety, and processing are just a few factors to consider.
My name is Chris Lian, and I want to walk you through how we make an industrial solid-state drive, or what's commonly known as SSD. Let's get started. Like coffee, not all SSD are created equal. No two coffee beans are exactly the same, and every NAND block inside an SSD has a different quality variance.
SSDs built for industrial and embedded applications face many challenges. They are typically installed in space-constrained systems. They operate for long extended periods of time in harsh environments and often face power and thermal challenges.
So, at the end of the day, how do you know if your purchased flash storage solution from the SSD manufacturer can meet or even exceed the expected product lifespan? First, we evaluate the application data usage workload based on drive write day, operational temperature range.
Second, selecting a suitable NAND that is right for this application based on terabyte written NAND technology.
Finally, when the drive is assembled with the selected NAND, the drive is then put through a stringent screening test. You can think of this step as simulating a thunderstorm or heat wave within the drive to test whether the drive or block can meet the client's requirement. At ATP, we call this process Rapid Diagnostic Test, or RDT for short, where we conduct 100% screen on every device in every area of the drive with our self-built proprietary tester.
There are many parameters tested under RDT, but for simplicity's sake, I want to highlight the two most important elements, which are the ECC and temperatures. As an example, let's dive in on how we make SSDs that can operate from -40 to 85 Celsius.
RDT helps us make sure that our product can endure extreme operating conditions. Based on predetermined ECC criteria, we use stress accelerants such as temperature and power to help us identify weak, unusable blocks and to improve drive reliability and endurance. Many module houses perform reliability tests according to their standards. At ATP, we believe in uncompromising quality that meets and even goes beyond market standards.
For example, other module houses only test at room temperature or 25 Celsius, which does not rigidly screen the NAND nor tests the true strength of the ECC. As a result of the relaxed criteria, few errors are identified because there is not much ECC performance difference for strong and weak blocks. This causes the weaker blocks to be hidden behind the ECC. Because these weaker blocks have not been marked as unsuitable, data will be unknowingly written onto them. On the field, they will also be exposed to temperature challenges, ultimately compromising the reliability of the drive and causing early life failure.
In contrast, ATP tests not only at room temperature but also in extreme ranges up to 85 Celsius, where more errors will appear. This challenges the strength of the ECC and pressure it to correct more errors. As the ECC correction threshold is reached, we can then mark more weak blocks as unusable or uncorrectable. In actual use, data will be written only on the robust blocks, and the drive will be able to withstand harsh temperature ranges on the field. This minimizes early life failures, extends device endurance, and ensures the reliable operation of the SSD during its entire service life. Another difference is that while most module houses typically test only the user area, we test the entire drive from user, meta cache, spare, and firmware areas. With ATP RDT's more stringent criteria, only the most reliable and enduring drives are delivered to our customers. This screening process does not only weed out defective components to prevent early life failures, but ultimately, it ensures that the products will deliver superior and reliable performance within their guaranteed lifespan. If you want to learn more about how we set criteria by conducting NAND IC screening for RDT, you can check out this video. I hope you have learned something new with this video. If you would like to know more, please subscribe to the channel so you will get notified for the next part of our video series. We will give you a more in-depth look at how ATP makes industrial SSD. Enjoy a cup of coffee. See you next time.